So, um, this is just a check-in, guys. We'll go through kind of what is due today, and then I'm gonna open it up to you guys to ask any questions that you have. Okay. Sweet. Okay, it's hard to believe it, but we are in week 12, which means there's only 3 more to go. Nope, 4 more to go. 3 more of instruction, and then 1 of finals. So we're getting close. Sorry, I should have had this pulled up and I didn't. So, as you guys have probably already seen, we are jumping back into chapter material. So following along with the chapters of the Singer text. And so this week we are working on chapter 10, which is all about spermatogenesis. So we've spent most of chapter 6, 7, 8, and 9 on the female cyclicity, and chapter 10 is dedicated specifically to the male side. So talking about how sperm are actually created, how they grow, how they mature, and those type of things. So that whole term spermatogenesis really refers to how we generate sperm cells. And so there are the note guide, as well as 1, 2, 3, 4, 5, 6 different video lectures for this week. And then there is the chapter 10 spermatogenesis quiz as well. And so that's due Friday the 12th by the end of day. So that's what we are concentrating on this week. And so there's lots of intricate detail associated with spermatogenesis. And so I broke it up kind of by category. And so whether we're talking about spermatogenesis as a whole process, the spermatogenesis and how it's controlled from a hormone standpoint, how individual sperm cells are processed to become fertile, how they differentiate, and then the whole process of spermation. So how sperm cells are actually going to be able to be the fertilizing mechanism to the female. All right, so that is what we are looking at this week. Last week, you guys had the opportunity to really dive into estrous synchronization in a lot of different species. And it can get a little bit overwhelming. So there's lots of hormones that work differently in a lot of different species. And so hopefully that provided some decent material for you, especially as we move into the group projects or the end of the semester projects. Not everybody's doing it as a group, because that's some really good tools that you can use for like making improvements in your scenario and your goals and that type of thing. So I just wanted to make sure we were all on the same page about what was due this week. And then I'm going to turn it over to you guys to answer any questions that you may have.
I have some questions regarding the project, but I figured I would ask you later because it's like very specific on like certain topics of reproduction. So
okay,
I don't know. I figured I would wait until everybody else has their own questions.
Okay, great. Peyton or Hannah, do you guys have questions about course material?
Yeah, I had a question about the stuff we're going over this week. So like the basal and the lumen and like that, I was confused on what, I knew it was like different layers, but like I wasn't sure of what, like I was a little confused on that part.
Yeah, it's because it's like microscopic, right? And there's that basement membrane is what really separates like the cells that are going to respond and produce testosterone versus the cells that are actually going to turn into sperm cells. So let me pull this up and maybe I can provide a little bit more clarity. It's taking its sweet time, sorry. Okay. Okay, so I think this is what you're talking about, right? Okay, great. So this, keep in mind that this is going to be in the seminiferous tubules that are going to be in the testes. So these things are super tiny. They look like spaghetti, and they're going to be wrapped up in lobes. Okay, and those lobes are going to make up the testicle. And so these really tiny seminiferous tubules have a couple of different compartments associated with them. So down here, this basal membrane, you can kind of think of almost as a bigger, more pronounced version of a cell wall. So it's going to keep the contents in the seminiferous tubules and separated from the Leydig cells that are producing the testosterone, right? So the Leydig cells are going to be down here. And so those Leydig cells are really important for producing testosterone, because if testosterone stops, then the Sertoli cell growth is going to stop too. That's why there's only this little itty bitty basal compartment that separates them. So it's enough to keep cell specificity differentiated, but it's not enough that it stops signaling. Okay, so as long as the Leydig cells are producing testosterone, those Sertoli cells are going to keep maturing to become sperm cells. So on the seminiferous tubule portion of this figure, so everything here, the part that is down closest to that basement membrane is going to be really immature sperm cells. Okay, so they are not functional. They are infants. Okay, so they're babies at this point. Just to kind of just to compare it to us as humans. So we have this baby Sertoli cell here that is going to eventually mature into a sperm cell that looks like this. But right down here is like a baby blob, okay? And we call that spermatogonium. And these words are super scientific, like baby blob, okay? So anyway, just kidding. But there are different versions of spermata, fill in the blank, that actually signify the maturity of that sperm cell. Okay, so spermatotids are going to be sperm cells that are fully physically developed. They are not at this point fertile, like they can't fertilize an egg at this point in time. And so we actually won't see fertility occur until the sperm cells get out of this luminal space into the epididymis. But so we start with these little baby Sertoli cells, and they are going to move this way. So in this figure, just the way that it's oriented, they're moving up. But keep in mind that these are in those seminiferous tubules. So they're actually moving towards the lumen of the tubule, okay? And they're going to pop out of the lumen into the tubule and make their way towards the epididymis. And so after they go through these stages of development, so our spermatogonium is going to move into a primary spermatocyte. And keep in mind, at this point in time, this is going through meiosis and mitosis, right? And then that primary spermatocyte is going to mature into a spermatotid. And it's not until we get to the spermatotid stage that we actually start to see the head of the the sperm cell being developed, and the mid piece and the tail. And so it's just like, an infant that's growing, right? So they look like a little baby blob when they're newborns. They get some character once they get to the infant stage. Once they get to the toddler stage, they look pretty different. And when they get to puberty, they look really different. And so this up here is kind of like that pubertal stage. And so that the portion of growth that occurs in the basal compartment is where those Sertoli cells are going to be generated, and they're slowly going to start moving towards the adluminal compartment. And as they move that way, they're also maturing and growing. So Peyton, I don't know if that helps or hinders your understanding, but did you have a specific question in there based on my explanation?
No, yeah, that helped a lot. Like, I was just kind of unsure about like the way that it moved, but yeah, that helps.
Yep, it is. It's really hard to visualize, right?
Yeah, like it's just hard. Yeah.
Yeah. So we see this type of stuff and like from a microscopic point of view, but and we do our best as scientists to like make drawings of it, and it's still really hard to get your mind around.
Yeah. Oh, thank you.
Yeah, you bet. Great question. Awesome. Any other questions about stuff prior to chapter 10 or chapter 10 itself before we jump over to group project stuff? Okay, cool. All right, so I know Caleb has specific questions about his group projects. So Peyton and Hannah, how are your group projects going? I gotta stop saying group. They're semester projects, okay? So you might be doing them individually or as a group.
Yeah, I've been like I just have like I need to start mine still. I haven't like got to the point 'cause it's like all the other like classes like I have research projects. I'm just trying to figure out where
Okay.
So I still need to start mine, but
have you had a chance to read through the scenarios? Like, do you know what scenario you want to do, or are you still at that stage? You need to choose a scenario.
Yeah, I have a group. We're doing a scenario 9, I think it is.
Okay.
So
Yeah, we've talked before, right?
Yeah.
Yeah. Okay.
Yeah, I just need to get started on my part, but
cool.
Yeah.
Awesome. And Hannah, what about you?
I'm in the same boat. I'm waiting to start mine. I did have a question. I don't know if anyone had asked this yet. In ANSC 271, we're having to do a beef production calendar. I didn't know if those could be kind of synonymous since we kind of have to make a production calendar type deal with this project. So, but I didn't know if it mattered if we used the same kind of format.
Yeah, that's totally fine. So, Dr. Smith and I teach pretty similarly. So, we really want you guys to take home the production application side of this stuff, which is why we do the scenarios in this class and why he's probably having you do scenarios in that class. And it's not going to be the last time you see a production calendar. And just for our sake, like a production calendar is fantastic because it gives you an overview of how the whole operation runs, but we're going to really focus down on the reproduction aspect of it. So that's why I'm having you guys detail out like your reproductive specific goals and the strategies to move you towards your goals, and that type of thing. And if you want to include like some broad nutrition stuff, some broad, selection things, those type of things, that's great. But we're really going to focus on reproduction.
Okay, awesome. Thank you.
Yeah, you bet. Great. Okay. Well, I'm going to pause the recording.